Hai semua, dalam video ni kita akan bincangkan the reaction mechanism untuk electrophilic aromatic substitution of the benzenes. Untuk menulis reaction mechanism for electrophilic aromatic substitution akan melibatkan 3 langkah umum, iaitu Step 1, formation of electrophile, Step 2, formation of arenium ion, and Step 3, deprotonation of arenium ion. Mekanisme tindak balas yang pertama yang kita akan bincangkan iaitu bagi tindak balas halogenation of benzene. Bagi tindak balas halogenation of benzene, reagen yang digunakan iaitu halogen seperti chlorine dan juga bromine molecules in the presence of Lewis acid catalyst seperti AlCl3, AlBr3, FeCl3 dan juga FeBr3. Jadi seperti yang kamu dapat lihat pada slide, the general reaction for the halogenation of benzene iaitu benzene bertindak balas dengan halogen molecules with Lewis acid catalyst seperti AlX3 menghasilkan produk of substitution of one hydrogen atom in the benzene ring with the X atom. Jadi sekarang kita akan lihat contoh penulisan mekanisme untuk tindak balas halogenation of benzene. Jadi kita lihat contoh yang pertama. Let's say we have a reaction between benzene with chlorine molecules in the presence of aluminium trichloride catalyst. So the reaction will produce chlorobenzene as well as the HCl. So, how to write the mechanism for this reaction? The first step to write the mechanism is to show the formation of electrophile. So, to form the electrophile, we need the halogen molecules. So, in this reaction, we use the chlorine molecules, react with its Lewis acid catalyst, which is AlCl3. So the chlorine atom will share its electron pair to the aluminium, which is electron deficient. So the sharing electron forming a bonding between the chlorine atom and the aluminium atom. So since the bonding form makes the chlorine lack of one electron, so this makes the chlorine is partially positive, which is chlorine form a positive one charge, while the aluminium gain one electron from the chlorine atom. So now it has one extra electron, so that makes the aluminium become partially negative or with one negative charge. So this complex form makes the product as an electrophile. The second step is to show the formation of arenium ion. So we have a benzene react with the complex that formed from the first step, whereas the pi electron from the benzene ring is a nucleophile that attack the electrophile from the complex, whereas it takes one of the chlorine atom from the electrophile and breaks the bond between the chlorine-chlorine atom. So now the benzene form a new bonding with the chlorine atom. But this process has disturbed the pi system in the benzene ring, which makes the benzene ring having one positive charge to one of the carbon in the benzene. So this structure is known as arenium ion. So the arenium ion shows that the electrons in the pi system of the benzene ring, we know that it's able to delocalize to make it more stable. So since the carbon, one of the carbon here having a positive charge, so that shows that that carbon is electron deficient, so it makes the benzene ring become less stable. Thus, the pi system will move or delocalize the electron to make it more stable. So the electron pi will move in a circle. So we can show the resonance structure, where is the first step, the neighboring pi electron will move to the carbon which is positive and form a double bond. But then when they form the double bond to that carbon, so the carbon that donate or transfer the electron pair is now become positive. And the process is keep moving the electron pi. So the neighboring pi electron now move the pi electron to the positive carbon and become the carbon-carbon double bond. But then the carbon itself become positive. So the process is keep moving the pi electron in the benzene ring. So this is what we call the resonance structure. So now, for the third step is deprotonation of arenium ion. So in this step, we are using one of the arenium ion that has been produced in the step 2 from the resonance structure. So we just take one of the structure and react with AlCl4 1- that has been produced in step 2. So in this step, the aluminium, negative aluminium, we remove the proton from the arenium ion and restore the pi system in the benzene ring by moving the bonding pair inside the benzene ring. So now we have produced this product, a chlorobenzene, which is stable with its pi system that has been restored. And we also get back the aluminium trichloride, which is the Lewis acid catalyst, as well as the HCl. Now let's discuss example number 2. Let's say we have a benzene that reacts with bromine molecule in the presence of FeBr3 and produce a bromobenzene. How do we write the reaction mechanism for this chemical reaction? The first step, we have to show the formation of electrophile. So the reagent used in this reaction is the bromine molecule as well as in the presence of the Lewis acid catalyst FeBr3. So the electron pair from the bromine atom will attack the ferrum, which is electron deficient, and forming a single bond between the bromine atom and the ferrum. So this makes the bromine become partially positive with positive 1 charge and the ferrum with partially negative with negative 1 charge. So this product form a complex that can be classified as an electrophile. For the second step, we have to show the formation of the arenium ion. So to show the formation of the arenium ion, the electrophile of the complex will attack by the pi electron from the benzene ring and breaks the bond between the Br-Br atom. So then the bromine atom will attach to one of the carbon in the benzene ring and form the arenium ion. So as we know that the benzene ring has an ability to delocalize the pi electron in the benzene ring. So since in the arenium ion, one of the carbon in the benzene ring has a positive 1 charge, so this destabilizes the benzene ring. So the pi system will delocalize to make it more stable. So how to make the carbon positive become more stable in the arenium ion? So we need to delocalize or transfer the electron, moving to one carbon to the next carbon. So let's say here we have a positive carbon, so the neighboring pi electron will move to the carbon positive to make it more stable. So we move here for the first pi electron and forming a product of pi double bond between the carbon. But eventually the carbon now become positive carbon. So the process keep continue, whereas the neighboring carbon will move a pi electron to the positive carbon and become a double bond. But then the carbon itself now become carbon positive. So this is what we call the resonance structure, whereas we have the same type of ions but different arrangement of electrons. The third step is the deprotonation of arenium ion. In this step, FeBr41- will remove the proton from the arenium ion and restore the pi electron in the benzene ring. At the end of this reaction, we will get a stable bromobenzene, as well as the Lewis acid catalyst FeBr3 and the HBr.